Hey everybody. I learned a little more about percentiles the other day. I did a deep dive because I was bothered by inclusive and exclusive in Excel and just kind of like trying to wrap my head around it. And feel like I have a better understanding now, so I'm going to try to lay down some knowledge. Here's the data set. A bunch of students measured themselves. Sorry, reported what they thought their heights were, then measured themselves. I converted that into inches. And then I looked at differences with absolute values. So I got a bunch of numbers here. All right. And first thing I want to do is to kind of talk about the concept of percentiles, which I think it's easier to start with talking about the concept of quartiles, right? If I have a bunch of data, let me get my annotation tool out here. If I have a bunch of data, I can split my data into 4 sections. 25% of the data is on the left, 25% of the data is in here, and 25% of the data is in here. So 3 lines is all I need to cut my data set into 4 sections. And I'm sort of imagining everybody lining up in order here. So for instance, I could take my data, put an order to it. Let's say the measured values here. I'm going to bring it over here. I'm just going to sort it real quick. And there we go. Okay, so I can imagine breaking this into little fourths, quarters, quartiles. And the problem, of course, is that not every number of numbers can be divided by 4 perfectly, right? So then I have this problem of like, okay, what do I mean by the quartile point here, right? This is the line below which 25% of the data exists. This line here is actually the median, is the line that marks the distinction between the second quartile and the third quartile. And of course, I can use the median to accomplish that. But the general approach is that, well, first of all, one of the things I find fascinating about this problem is that there's actually different ways to do it mathematically, and sometimes you come up with different answers. So the easiest way to show that is just to say, notice that when you find the quartiles in Excel, you get these 3 different choices. So .exe, .inc, and then quartile, which has a little exclamation point down here. This is deprecated, so they don't suggest that you use it anymore. I suspect that this quartile is one of these, but they're trying to be more clear about different approaches to finding it. So I'm just going to show you, and I don't actually know, so I hope this works. I always like to do real data. Oops, sorry, comma 1. So this is looking at this data, and I'm looking at the first quartile. Goodness. Yep. And then I'm going to do that again, but I'm going to use the quartile inclusive. And yippity hop. And 1. Yeah. So you can see I get different answers. And this is sort of unsettling. I mean, notice that the numbers are pretty close together. So it's not like you should be panicking. The point is that there are multiple answers to the question, what is the first quartile? Because there's different approaches to finding the first quartile. So what I wanted to do was kind of explore the methodology for that. And then, you know, just leave it up to you to decide. I mean, it depends on the situation. Maybe it depends on the instructor, or are you doing computer-based homework and they have a particular, you just have to be very clear in your own mind. If it's just for your own purposes and your own statistical calculations, I suspect it doesn't matter, but you want to be consistent in how you do it. All right. So how does this 60.75 get calculated? So first of all, the basic approach to a quartile, actually percentile, any kind of situation would be to set up a fraction representing what I'm trying to do. So 1 out of 4 is the first quartile. and I would multiply that by, and this is where the approaches differ. 14 plus 1, I think, is the exclusive approach. And this gives me the data point that marks the positionality of this line here, right? So I'm taking 14, I'm trying to divide it, and I'm saying this is the point where I would get the 25% mark. If you're confused about the +1, -1, keep in mind that if I have, say, 5 data points, let's say X, 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 the number in the middle is 3. It's the third number. And if I want to find that mathematically, I can do 5 plus 1 divided by 2. So the +1 is a way of arriving at the center based on the fact that I may have an odd number. There's another way to arrive at the center, which is to actually take 1 away from my 5. So I have X, 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 and then I just divide by, so this is 5 minus 1 divided by 2. This also will get me to the center spot. The second position is the central number. So this is how I sort of conceptualize why this +1, -1 is happening. And so that's actually what happens here. We do the 1/4 because we're looking for the quartile. We multiply by 14 minus 1, and this gives us the middle number. So now what I need to do is I branch this into 2 parts, which is if I'm at the 3.75 number, there is no 3.75 number. There's a third number and there's a fourth number. And the same happens here because I'm between the same numbers, 3 and 4. So 3.25 is between 3 and 4. 3.75 is between 3 and 4. The difference is that this one is a little closer to 4. This one's a little closer to 3. So this is where interpolation comes in. We sort of look at the third data point, we look at the fourth data point, and then we think, well, if we're 0.75 between those two things, then I'll go 75% of the way between them. All right, let's put our wheels on the ground because I don't know if those words made sense. The third data point is, and this is in the exclusive approach, the third data point is, here's 1, here's 2, here's 3. This is the exclusive approach. I'm using all of the numbers. I've added an imaginary 1 to divide by 4 in order to get to the first quartile position. This is the fourth number. And so I'm looking between I don't think I used the same numbers. DS, no, I don't know. Here we go. Yes, sorry, I was going to confuse myself. All right, hold on a second. Beep, beep. No, wait a minute. I can just copy. I can autofill to the right. There we go. Okay. Okay. Whew. I was like, oh my God, I'm crazy. So between the third and fourth number, there is no difference. And so the interpolation would be anything between 3 and 4, 3.2, 3.75, 3.9 would still be 62. Let me try to draw a visual of that. It's like I have a little kind of thinking of XY situation, right? Where I've got this point here and I've got this point here. And I'm like, well, where would the middle number be if I was at 3.75? Well, it's exactly the same because it's a straight line across. Where it gets interesting is when this second point is not the same, then I'm trying to use interpolation to figure out, well, I would probably be about here. And that's where this 0.25 is coming from. There is no 62.25. Where does it come from? Let's look at the process. Then we'll repeat this with percentile. So in the inclusive approach, I remove the first point, and then I start counting from here. Oops, 2, 3, 4. So this time, the third data point is 62. And the fourth data point is 63. And now I do have a little bit of work to do. The difference between 62 and 63 is obviously 1. But instead of being lazy and just saying, well, I'll just take, the average of those two numbers, the mean of those two numbers, what I'll do is I'll interpolate because I'm at 62.25. So I'll take the first number, 62, and I'll add on 0.25, which is the decimal part of this number, times the difference, which was 63 minus 62. And so this is where I end up with the 62.25. So this is how the inclusive approach works in Excel. This is why you get a different result. Now, bear in mind that if I do the median of the median, I actually can get a third answer. So that's a totally different way to get the quartiles. But the median of the median only works for the quartile concept. So better to sort of think about it this way, I suspect, if you want to think about it at all. And by the way, I don't know that you need to think about any of this. It's like this is really deep into how these things work. But again, the reason I think this is kind of interesting is because it represents a place in mathematics where there's not a right answer. There's two different ways to come up with an answer. Both of them are valid. And, I don't really know how much more to say beyond that because I'm not a percentile expert. Okay, so then let's do a percentile problem and just kind of go through the same thing here. And I'll delete some of this. Maybe we can find an interesting percentile. So we're going to do the 30th percentile. And let's take a look at that. So 30th percentile, I'll just do a percentage times, and then the exclusive, let's start with that, 14 plus 1. That would give me this value. And the inclusive approach, 30% times, and then I would have the data set minus 1. And so interestingly here, we've got actually apparently two different pairs of numbers, because 4.5 would be between 4 and 5, and 3.9 would be between 3 and 4. Okay, so let's take a look. We're going to predict this time. We'll predict the values, then we'll use the percentile tool in Excel to actually do it. So between the 4th and 5th values, we would be between 62 and 63. Between 62 and 63 is a difference of 1. I don't know why I'm doing this, but I'm just trying to slow down and show it. So then I start with the lowest number and I add the decimal 0.5 of the difference, which is 1. And so I'm going to end up with 62.5. So my predictions, just to check that I'm doing my math right, is 62.5. And then my inclusive, let me just mark this as exclusive. And then the inclusive version would be the 3rd and the 4th positionality, but starting from, because we've eliminated the first number, that's the minus 1. Oh, interesting. So 3 and 4 actually ends up in exactly the same place. The difference is 1, but this time we're not adding 0.5, we're adding 0.9. So we end up at 62.9. So I have two different predictions for the 30th percentile, and now I'm going to use Excel to prove that I understand how it's doing it, because it'll get me the value, and I'm doing it on the measured. Let's not mess that up again. Oops. And then I need to put the 30th percentile, which is 30%. Hey-o, percentile, inc. And I'm going here, and I'm going 30%. Bingo. Good. So that's a sort of a deep dive. You've got the how to do it by hand. Turns out there's multiple ways to think about it, not just one way to do it. And then you've got the matching Excel formulas, which will crunch the numbers for you, in no time. So I hope that was helpful and interesting. I always think it's fun to kind of explore the hidden, meaning behind things. I actually think that there's more ways to do percentile calculations. I was kind of looking at some articles about it, and yeah, so this may only be the tip of the iceberg. All right, hope you enjoyed that.